Someone turned it on, thank you. So this is a combined meeting between the TEAS working group and the MPLS working group. The theme is mostly young models, and we will take a look at the overlap of young models between, actually not so much an overlap in the model as an overlap in the interest in the models we are focusing on. We have, I think, 4 presentations, and with that, Lou.
So we have the usual note well here. We are doing our normal audio and minute taking, Jabber Room, and I tend to like Etherpad. I don't know who did you have to take notes? Okay, and hopefully you're in Etherpad, and if you're not, that's okay. We do have at least one remote participant, our one of the co-chairs. Also, we have Meet Echo. Please stay in the box, use the mic, and follow the normal rules of announce yourself when you come to the mic. With that.
So it's always amazes me, but when you say that, you're always out of the box.
You know me.
So welcome. I think we jump straight to the first presentation. And first up is Cameron. So please remember that we are trying to sort out the overlapping interest between the 2 working groups. So address that in your presentation. And that goes for all the presenters.
Okay. Hello, everyone. Good evening. I am Kamran Raza from Cisco Systems. Actually, I'm going to present 2 drafts. First of them is version 00, and the other one is just an update from a previous draft. So first draft is about Yang data model for MPLS base and static LSP. Set of co-authors you can see on this slide. So in this document, in this draft that we posted right before the IETF, we are specifying 2 Yang models, MPLS base and MPLS static LSP. The base model is really small portion of it. It's mostly MPLS static LSP. The MPLS base model serves as a base framework for configuring and managing an MPLS switching subsystem, whereas MPLS static LSPs defines Yang data to configure and manage MPLS static LSPs. And MPLS static model augments MPLS base model. So going into a little bit more details of each of these. So MPLS base model that we are defining is augmenting routing core module, which is defining netmod routing config internet draft. But it has some additional data which is specific to MPLS switching. Right now, we don't have lots of data there, but this is just a framework to begin with, and we will enhance it as we go. This base model augments routing instance, and hence it allows MPLS protocols that would augment this model to be running under a given routing instance or a WRF instance. Additionally, this model also defines MPLS interface list. There was some discussion earlier today in T's working group session on MPLS interface. So this kind of also, I have a slide to present this. It also defines base MPLS label and some other base definitions that other models in MPLS or even IP can use from this model. And last but not least, so we expect that other Yang models in MPLS, such as like LDP or some of RSVP, TE, will augment this base as applicable and where applicable. Right, so base tree that we are defining in MPLS base is as follows. So it augments routing instance, and it defines its own MPLS leaf underneath that instance. And any MPLS protocol that basically wants to run under routing instance can augment this MPLS base tree by defining its own tree underneath this MPLS. An example, we have a second part of my presentation is on LDP. So for example, we'll see in LDP that we are augmenting MPLS base in our latest revision. This model also defines a state tree, which is of a routing state. While we are trying to align with open config state, we are still keeping routing state tree in our MPLS base model until we get a consensus on a routing level that how are we going to represent state for a given protocol. So in MPLS-based interfaces, so what we are doing is that we are defining interface list under MPLS base model. Basically, what it means is that it defines an interface where you want to enable MPLS. This does not mean you're enabling control plane. It just enables MPLS forwarding, basically encapsulation or decapsulation on a given interface. So the MPLS base is already defining a MPLS base interface list. As follows. So you have an MPLS and you have interface list and routing protocol or an MPLS protocol that wants to use an MPLS, that wants to enable an MPLS control plane procedures on a given interface can reference this interface, which is defined in MPLS base interface list. What I'm trying to highlight here is that if you have a protocol, when you reference this interface from MPLS interface list, forwarding is already enabled because it's already an MPLS base interface list. This is assumption. All you are doing by referencing it is you are trying to either enable your control plane procedure on that interface, or you're trying to define some additional control plane related procedures for that particular interface in your protocol. Again, we will for example in LDP, if it has to enable LDP discovery on an interface, so it will reference MPLS interface from the list, assuming that MPLS forwarding has already been enabled on that interface. So we have a couple of dependencies. Of course, we are augmenting core routing data, core routing module. So, if there's any change happens on the routing instance, whatever, so we will be impacted. But we are keeping an eye on this. And other point that I made earlier was about the state tree. We have defined routing state for MPLS. However, the models that wanted to be aligning with MPLS open config style of state, they may or may not use this tree. But right now, our model defines routing state for MPLS as well. So next step for this is basically we are looking for some comment. This is very minor work that is part of this draft. Probably I'll take comments on this before I move to second portion of this draft, which is about MPLS static LSPs. Any comments, questions, suggestions?
Sorry, being slow. So question is, how much is left to align with the other models that you depend on and depend on you?
Yeah, I guess for MPLS base, there's not much left. However, there are some pending things like state. So we have defined routing state under MPLS. But my understanding is that this is still being discussed, that whether we have all kind of state intended, applied, and derived under same tree of routing/routing instance, or we define derived state under routing state routing/routing state. So I think that's the main pending item that we have in our draft. Otherwise, it has the basic framework. It's very, very simple, really, work that we are doing. Not much.
Okay. Given the set of overlapping authors, I'm not too surprised at the answer. Thanks.
Sure.
Okay, Tariq Saad. I'm a co-author of this draft, and in its current form, the draft has both modules, the base and the static. My understanding is the working group chairs prefer that we split into two different drafts, or is that not the case?
I don't think we have expressed a preference.
Okay.
But we told you to consider splitting them. So that's, if you come back and say, no, we don't want to split them, that would be disaster. We will accept that, but you need to consider splitting them to document.
Okay, thanks.
Yeah, but I guess I would probably at minimum, the draft name should reflect this. Right now, draft name is MPLS-static.yang. It should be MPLS-base-static.yang, so people know MPLS-base is defined in this draft.
Yeah, but that is a very, very easy comment to address when we make it a working group document.
Yeah, the reason we haven't changed it yet because we are still waiting on this, this decision. Okay, any other comment? All right, so No, I'm static. I haven't done. This was just. I'm still on the older slides. Okay, so as in the same document, we have also implicit-static LSP defined. So implicit-static LSP augments this MPLS-based model that we just presented, and it defines parameter related to implicit-static LSP configurations and state. It follows the approach in terms of configuration and state. It follows the approach that open config net state open config state model follows, meaning that we define both intended configuration and applied state within the same tree. At this point, we don't see a need for a derived state for a static LSPs because there are no protocol aspects of it. So only we have intended state and applied state in this model. And this model is consistent with IP static model, which is currently being defined under routing, netmod routing config. Our initial focus is on IP unicast and P2P LSPs. From the earlier session in routing working group about comments from on IP static and I2RS, and there are many static activities going on. So we are keeping an eye, and probably will also leverage some of the work done in other modules to be used in implicit static. Right. So basically in implicit static, we defined it has only really 3 building blocks. We have in segment, we have an operation that we perform on in segment, and this out segment. So in segment is basically for your lookup for your FAQ, then you apply an operation on that FAQ, and as a result you forward your packet, and there are different type, and you can forward your packet on single or multipath. So this model basically defines a set of definitions for in segment operations and out segment. So this is pretty much it's a summary of what I just said last minute, that you have in segment. So currently we have defined only 2 types of lookups: IP prefix based lookup or a label based lookup, or local label. And then you can perform based on this lookup, then you can perform an operation to forward your packet. And operations currently is you can do an imposition, you can do swap, you can do pop. These are basic MPLS. You can do pop and impose. The star really means that you can impose more than 1 label. And last but not least is pop and lookup. After all these operations, eventually, of course, packet gets forwarded using your out segment definition, where you can have 1 or more paths, forwarding paths defined. Yeah. So right now we have 2 types of forwarding path defined. One is simple path, and other is a set of path list. Simple path is very basic path. This is following the approach which is already in IP static defined in routing config model. And right now we have defined some path attributes, but not all. But this is just a revision 0.0. So I think I'll just skip further. Right. So next step for this is really to update this revision 0.0. We posted right before IETF. There's some work to be done, especially explaining our adding some section to explain our objects. We will do in the next revision right after IETF. We have to enhance our model beyond some basic LSPs, maybe different type of next hops and enhance path attributes, and leverage and also reuse some of the definitions which are already in other modules like netmod routing model or I2RS RABinfo model. And we are seeking comments from working group on this work. Any questions, comments, suggestions?
Robin from Huawei. I think that this afternoon in the RTG working group truly talk about the network instance, the YANG model. So because the static RSP is also the entry in the network instance. So how to synchronize this work? Do you have any plan or have been synchronized?
No, I just learned this in that last session. So we'll probably meet as co-author and we will try to synchronize, and we'll also discuss and engage open config team in for this work.
The second one is what's the relationship with the MPLS-TP and what's your plan? Because I think static RSP is easy to think about the MPLS-TP. They also use some of the static RSP. So I'm not sure what's your plan on the MPLS-TP.
Yeah. Currently, plan is not to have MPLS-TP as part of this work. Current focus is mostly IP unicast and P2P LSPs. We may have P2 MPLSPs later on, but MPLS-TP is not currently in our scope. But we can definitely revisit this later on.
Okay, so even in the MPLS design team, there's no, until now, no plan on the MPLS-TP, right?
For MPLS-static, yes.
Okay.
So Tarek Saad from Cisco. So MPLS-TP, we think it deserves to be in its own draft or module rather than sticking stuff in LSP static. That's something that we wanted to tackle, but we haven't yet. So that's on our radar.
Is the question on the same topic or a different topic?
No, different.
Okay, then before we leave that topic,
Okay.
before we leave that topic, can you answer where does MPLS-TE fit in?
Yes, so that's probably our next phase of work.
Yes, we will be presenting where MPLS-TE sits in this picture. Did you mean RGPTE in that sense?
I meant MPLS-TE.
MPLS-TE in general.
Yeah.
Okay. So yeah, exactly. So we have a presentation coming up, and there will be.
What about what's the relationship between this work, static LSPs,
Right,
and MPLS-TE static LSPs?
they're parallel and they're not related, but they're both augmenting MPLS base.
Okay. I would have expected your answer on TP to be TP is a case of a static TE LSP, but you didn't say that.
We think TP brings in a rich set of features, running on unnumbered or non-IP interfaces. So all this, which is not necessarily TE.
Well, since we have a talk on TE, we should get there, but I think you're missing something because TP is a profile of TE, not a addition.
It's an extension. Okay.
So.
All right.
David from Mellanox. I didn't have chance to read the draft, but I just want to know whether you consider just global label space or per interface global label space?
Yes, it's global MPLS space. Okay. We haven't highlighted in this draft, but we'll in the next revision. Thanks for the comment. Okay. If there are no more comments, I'll move to my second presentation. Okay, so all this showing up. So this is an update to an existing draft. This is on Yang data model effort for LDP and MLDP, which is almost going on for a year now. And this is multi-vendor effort. You can see as authors here from Cisco, Alcatel, Juniper, Ericsson, Huawei, Ciena. And there are also several other contributors which are not listed here. So just a quick background for everyone's benefit. So we have a design team which is multi-vendor, and there are also a couple of operators that initially had joined us from, for example, from Orange or Comcast. This team was formed during IETF 91, and since then we are meeting weekly to make progress, to define and basically make progress on this Yang model for LDP/MLDP. Revision 00 was posted and presented in IETF 92 in Dallas, which covered basic LDP configuration and RPC notification. Revision 01 was posted and presented at IETF 93 in Prague, which covered MLDP side of things. And this is revision 2 was posted right before this IETF. And in this revision, basically main work is to align with some of the open config comments as well as also do some cleanup. So main changes in revision 2 that I'm just giving an update on are that now we are aligning with MPLS base. So now we are augmenting MPLS, which is defined in MPLS base, which was presented earlier in my presentation. And we also are aligning with open config operational model, where we are having we are doing intended configuration and applied configuration under the same tree. However, we still have our derived state under routing state tree. So that part of a state is not fully aligned with the open config yet, but we are waiting for a little bit more consensus on routing side before we make this change. And also we made some clarification in this revision from regarding the WRF usage in our model. So basically, before until revision 1, we were hanging off a routing instance as a routing protocol because MPLS base was not around. So now we have MPLS base. So in our latest revision, we are hanging off an MPLS as an MPLS protocol. So we are still able to run in a routing instance. For interface enabling under LDP, we did not modify our draft yet because this topic was still under discussion when we posted our draft. So we just closed in this topic almost during IETF. So in our next revision, LDP will be referencing MPLS interface to enable LDP on LDP control plane procedures on an MPLS interface as defined in MPLS list under MPLS base model. Yeah, for operational state, I think I already mentioned this, so I'll just skip it. And this model basically applies on both LDP and MLDP. So latest revision has this open config alignment for both LDP and MLDP, which basically is as follows. So you can see that for almost every leaf or set of leaf, we have a config branch and we have a state branch under routing. So this is for intended config, this is for applied config. However, our derived state that we drive in our protocol is hanging off routing state tree, and which we are working on. We have defined some of it, but we haven't added into our revision 2 yet. But right now we are hanging off routing state. So if a decision is to make all state under the same tree, then we'll just move our containers there. But right now, this is how it's defined in LDP model. Right, so there are a couple of pending issues on our side, not necessarily on working, that requires working group input. We have some LDP policies which are defined a little bit differently than they're defined in BGP. So we are trying to do some alignment on this side. So LDP, BGP-like policies are almost similar. And we have still to add derived state for LDP and MLDP. We have started this work. We have identified some attributes, but we have not updated this draft yet. So in the next revision, hopefully you will see all the derived state for LDP and MLDP. And hopefully by then, this work will be almost near to completion. So next step on our side, align further with MPLS base for interface enabling for LDP and MLDP, and extend this data model for derived state. And when we will be doing this, we already have been in discussion with Open Config team to work with us and be aligned with us. And finally, we are seeking comments from broader community and working group, especially from operators on the work which is already there. It's been almost a year, so this is revision, third revision of the draft. And we feel that, I think, working as a multi-vendor team has been working for a year on config side of LDP, MLDP, and has already identified, has already covered all the base features. Only remaining thing is a derived state, which we are working on. We think that this document is ready for working group adoption. Of course, this is work in progress. We will have to do a few more things, but authors think that this is ready for working group adoption. So I'd like to hear from chairs and the working group.
So now you put me into a problem. I'm one of the co-authors.
Yes.
I also believe, as all the other co-authors, that this is ready for working group adoption, but I will have to leave the processing or testing of that to Ross or George.
Sure.
So I will trigger that when we get back.
Thank you.
I actually have, hi Mancho, wait just a second. I have one question that I'm a little bit worried about on the overall Yang modeling for whatever area we're looking at. Mm-hmm. I think we can get tools that actually see how the things fit together and actually capture overlaps. That should be fairly easy. But what do we do about things where we actually left things out? Because they will never show up. So is that a completely manual process of actually going to look at, we have 4 models, they fit together like this, and there are certain overlaps, and we take those away. But where we have gaps, how do we actually, how do we figure that out?
So you mean the gaps in like in specific areas?
There is something somewhere which we haven't modeled in any model, and we think that there was modeled in that model up there, and that we can.
Well, I think anything which is common should go to MPLS base. For example, label was one thing common, so we added in label in MPLS base. There's no point in defining label in five different models, and also we were also debating that maybe we should define incoming local label different than outgoing label that should go to base. Interfaces was one common thing we defined in MPLS base. So probably I could see anything which doesn't fit anywhere going to MPLS base, and maybe that will make more sense to than MPLS base as a document on its own to going forward.
I hope you're right, and if you're not, you pay the dinner next time.
We will all see.
Okay, Himanshu.
So, Himanshu from Siena. I actually don't have a question on this, but I have a question on the static stuff for Lou, because you talked about MPLS-TE and the TP as a separate LSP, static LSPs, and I really want clarification.
I didn't say TE and TP are separate.
Well, you mentioned TE and a TP being a profile or a subset of a TE. So, well, just take a step back, and the question is with respect to the TE. I mean, what is a TE static LSP, right? Is it like per hop behavior, the diffs are TTL handling, LSP merge, penultimate hop, or are we what are we talking about when we say TE? As I know for TP, you can say, okay, you need to address. You have to have maybe if it's unnumbered, then you have to have a MAC address discovery. If it's Ethernet, what method are you using and all that stuff. But to get some sense of how we are distinguishing on the static LSPs. So we can complete this properly.
So
that's all.
So the TE part, I think, is in the next presentation. Right?
Static.
You're going to cover TE. So the question you're asking is about static TE LSPs, not static LSPs. And when I asked the question about the relationship before, Tarek said they're in parallel. So I'm happy to answer your question, but if it's not answered by the next presentation, come ask it again, and I'll give you the answer in that context. Because this is the non-TE LSP discussion.
Non-TE.
This.
Yeah, this.
All right. Actually.
All right. I'll wait for the next presentation.
If you don't see the difference between are you suggesting that there's no difference between a TE static LSP and a non-TE static LSP? Is that really what you're asking?
I want to know exactly what do you need to add on a static LSP is a static LSP. Is it just that static LSP has the label switching construct and or everything else is related to TE? The EXP bit setting, the TTL, the diffs per hop behavior, the LSP merge, penultimate hop pop, all those stuff is part of the T.
So from my standpoint, a TE LSP is in a generic thing and can cover any switching type that we support in GMPLS. And that TE LSP could be signaled via things like RSVP, or it may not be signaled. Maybe it's through a control plane, such as, we've heard about some interesting PCEP uses that are completely supported today, but no one really uses things that way. Or it could be statically set up through a management protocol. So I don't know if that helps.
So Lou and Himanshu, I suggest that we actually let Tarek do his presentation first, and then we return to this other person.
Sure. Yeah, no problem.
Any more questions?
We are out of time.
I didn't have time to go search the dependencies, but base MPLS, is that used by any of the TEAS modules? Mike.
Talking, we need to enable MPLS on interfaces that are TE, traffic engineering. Then we have to reference the MPLS base.
Okay, so
for that matter.
This is a comment more to the MPLS chairs than the authors, but once the documents are split out, it would be nice to see the base document become a working group document as rapidly as possible, given that we have working group documents in TEAS that depend on it.
So, okay, we can discuss the so would that be a reason to split the base part out as a separate document from?
You did notice how I phrased that, right?
Yeah, yeah.
So yeah, I think.
Okay, I have the reason, so we can go ahead and move on. Okay. So, Tarek.
Yeah. Thanks. Hello, everyone. My name is Tariq Saad, and this is we did a dry run of this presentation in the TEAS working group, and I'm doing it again now. I'm presenting an update on the two working group documents on the behalf of the team listed here. So the presentation will contain updates of the documents from the previous version, open issues, and next steps. The first update that we've done in the latest revision is we did split the RSVP module into two pieces or two modules. One is the base RSVP, and the other is the extended. In the base, we are putting all the core functionality needed to operate this RSVP protocol, and we're not allowing any if feature checks in there. So that means that it has to be supported on all LSRs that support RSVP-TE. This module will also contain features with minimal knobs, so as minimal as possible for the feature to work. As minimal as having one leaf that is to enable it. The defaults for this enable leaf is left out for vendor implementation, and the model that we're suggesting is not suggesting a default value at the moment. The extended module will introduce the extra knobs to control the features, so all the extra knobs that an operator would need to tune the feature will be there. It is optional, and it's allowable to use the if feature check in there. The second update we had is we know that the PCE, there is interest in the PCE working group in developing a Yang model for a central controller. And they've shown interest in reusing some of the groupings that we've defined already to maximize the reuse of the code or the model that we're developing. So an issue they pointed in our groupings is that they are device dependent. We are trying to solve this by offloading the device dependent nodes or attributes onto a separate grouping so that the PCE model or the central controller model can use the groupings that we have defined. The third update that we have is we are introducing RSVP as another protocol, just like OSPF and ISAS and the other ones. And basically that we're augmenting the routing instance path with RSVP, where every attribute of RSVP will hang off of that path, and that will allow RSVP to run in the specific instance. The fourth update we had is we tried to address the ephemeral states, specifically the tunnels and the LSPs. In terms of tunnels, we have a list of tunnels that we defined. They are read-write, and we think that the ephemeral tunnels that are derived or protocol created should hang off of the state part of the tree. The gotcha here, or one end result of putting it under the state and being hanging off of a read-write container is that the operator is allowed to delete this derived state, and we think that is not that is acceptable at the moment. So it means that a PCE created tunnel that is in there can still be deleted by the operator if they choose to. The second update that we did. The second update that we did for ephemeral LSPs is we put them in a separate state read-only list. And these LSPs are the ones that are created by protocols like RSVP. And they're not hanging off of a read-write or configurable. They're not configurable. They're derived by the protocol. Open issues, the first one we have, we talked, Kamran did mention the MPLS interfaces, but we did have an issue with RSVP interfaces. There were multiple options that were considered. If I want to enable RSVP on a specific interface, should I consider augmenting the routing interface list? So the list of interfaces that are in the routing module. If I do that, then because an LSP can span multiple routing instances, we thought that that is too restrictive. So the incoming interface and outgoing interface can sit in two different routing instances. So that is one issue that we thought that might not solve the problem. The second option that we considered is to augment the interfaces list. And as a result, we will be exposing the RSVP attributes under all interface types. This is still can be limited by adding when checks on, for example, IP-enabled interfaces. The third option is to augment the MPLS interfaces for MPLS RSVP-TE. And that's an option, just like MPLS LDP will be doing. It will be augmenting or referencing the MPLS interfaces, but it doesn't solve the problem for different technologies. And the last option that we considered is to have a separate list of RSVP interfaces in our module and maintain that. And we will be directly referencing the IETF interface list in there.
Tarek?
Yeah.
There's a fifth option. I don't know which one you're going to select, but you could also augment the IP or IPv6 augmentations in 7277 as opposed to the interfaces themselves.
Thank you. Yeah, that is possible, and we see there could be a small issue with that, specifically with RSVP-TE that could run on non-IP enabled interfaces. The optical and the non-IP enabled TP cases. But I think it's a valid point. But
the only reason I said that is AC Lindum again is you mentioned using a when statement as a constraint.
Right. Thank you. Yes, Shufai.
Yeah, comment on this. With the recent update for the IETF routing model, I think from AC, they removed that list. So the first option is not available anymore.
Okay.
Even before AC Lindum, even before the last revision, you could not augment that list because it was a leaf ref. It was just a ref. It wasn't to an actual interface. So you can't couldn't augment it anyway.
Okay. So we could have asked you.
You
to
could,
make it
if you have a list of containers, that would be okay. But if previously you have a lift list, which is not possible.
Okay. The second issue that we have still open is how do we enable MPLS on RSVP MPLS enabled interface. You could do that in 2 steps and ask the operator to first enable MPLS specifically on that interface, and then add the RSVP attributes on that interface. And we call that a 2-step approach. The second way you could do it is do both in one shot and try to enable MPLS and RSVP at the same time when you try to add any RSVP attribute. We did debate that, and we also got feedback from the operators, OpenConfig team, and we think we converged to the first option of explicitly enabling MPLS first, and then adding any protocol control plane attributes after.
How do you think it's going to work to have a data plane only interface that is controlled by RSVP but doesn't have a control channel? How do you represent that?
Yes, so this is specifically why we were leaning to option number 4 on open issue number 1. And option number 4 means that the data link and the control channel can be different. So your RSVP state can be sitting on an interface. You would enable
MPLS or TE on the interface, but not RSVP.
Yes.
And
so this is the out of band case, and there is the in band.
Yeah, I thought I heard Ina talk about disabling RSVP as basically an access control approach. So I guess I'm not quite sure how it's going to work out, but maybe that's at a too detailed level.
No, perhaps my comment in the previous working group was not about, it was about actually wanting to have explicit enabling.
Could you move a little closer? I can't hear you.
So we actually want to enable explicitly MPLS on an interface, not have it, as a side effect of having enabled RSVP.
Right.
And and this is opposed to what you had commented the other time, where which I really liked, having MPLS be implicitly enabled when you enable a protocol. But the operational feedback was that no, we do want that explicit node, because it's a method to control what traffic you allow on interfaces coming to you.
Okay, let me go back to. So on this slide, I'm showing the relationship between the structure of the different module, and hope that it will help clear some confusion. This is what we came up, and this is what we're executing. Came up with. So basically, we have a RSVP module and a base and extended version of RSVP. We have a TE module, traffic engineering module, and then we have RSVP traffic engineering, and then an MPLS RSVP TE module. So there are modules that we have not worked out yet, and we're targeting to address. One of them is Spring or segment routing traffic engineering, and specifically the MPLS data plane of SRTE or segment routing. The MPLS static that was presented earlier by my colleague here is augmenting the base, and it appears here. We think that MPLS TP will be parallel to this, but I think we need, I need, more clarification maybe with the chairs after, or maybe with Lou.
Parallel where? I'm sorry.
Parallel to MPLS static. So it'll be augmenting MPLS base. And you were thinking more of a traffic engineering.
Yeah.
Yeah.
I mean, we've always talked about TP as being a form
Traffic
of
engineering.
traffic engineering, so it would sort of seem to fit there. The part that you don't have here shown is the relationship with different switching types or different data plane technologies,
Right.
and how that fits in. You have that elsewhere, but not on this
I
slide.
tried to summarize on the slide, but I agree with you that the different technologies will fit in here. So we are showing MPLS because we are in the MPLS working group.
Yeah, but it's not RSVP. It's not about RSVP, it's about TE.
Yes, so the assumption is we are signaling MPLS TE LSPs via RSVP at the moment, and this is why we're ending up.
Right, but there are TE LSPs, which are non-packet and are not signaled.
Yeah. Are the static LSPs?
They could be.
Okay, so
could
can we
be
use the static model for that? Okay, that is the thing that.
Right, so
Yeah.
then we really, a base TE LSP should be a GMPLS LSP, meaning, or alternatively, is an LSP that can handle any arbitrary switching type that we support. And a packet is certainly one of them. And for packet, TP seems to be one of those.
I see.
And for certain things, there's no difference in terms of TP and a packet TE, other than perhaps how it's controlled.
Right. I think it's a valid point, but we need to, rethink it, how it will fit in the picture.
I think parallel is just fine.
Okay.
But I think it fits off of IETF TE.
Okay. Okay. Let's see.
Anyone who's welcome to disagree.
Yes, Robin.
Robin Huawei, previous slides.
Previous?
Yeah. Regarding this one. My comments is that similar. I'm not sure I'm similar as the Bluebirds or not. From my point of view, the static, from my point of view, is in fact it also has some the attribute of the traffic engineering. Has the attribute of the traffic engineering is not directly derived from the base MPLS base YANG model, because the static LSP you can configure the transit LSP without thinking about the route. So I think that is also has some the similar attribute like the traffic engineering. In fact, we can use the static LSP to implement the explicit path.
Okay, your comment is with regards to TP, right?
No, even can include the static LSP.
Static LSPs.
Yeah.
So to answer your question, Robin, so the traffic engineering contains more, attributes in terms of constraints on the path computation at the ingress. Now, how do you signal the path? That's a different thing. But we don't think static LSPs will need constraints or path computation, model in there. It's everything statically driven, and this is why I'm saying static will not augment the TE part.
Yeah, my comments is that static LSP to some extent is even similar as the SRTE is just implement the explicit path. That's the traffic engineering the attribute.
So again, with SRTE, there are constraints on path computation that you have to run CSPF and all that, produce a stack. And we think static LSP does not need to do any computation.
Okay, so I will later more discussion. Okay.
I'm unsure. Are you going to return to the previous question now, or?
Yeah, well.
We like 2 minutes, because then we need to let Su Feng to do his presentation.
Right, okay. I'll wait till you finish.
Wait 2 minutes or talk?
No, we have 2 minutes for questions now, and then.
My comment was that it seems that the IETF MPLS static YANG should hang off of IETF TE YANG. not at the base, but off of a TE yang, so you can get some of the TE specific parameters in the static LSPs, right? To have a per hop behavior and all that stuff. Yes?
I would like to discuss more to understand why you want to inherit traffic engineering attributes into static.
Keep in mind, static is for what we normally think of as LDP-based LSPs also. Right? I mean, that's the way I read it.
Not necessarily. I think
Not
static
necessarily, but
LSP.
it does include those. So you want to say all LSPs are TE LSPs?
Well, no, all I'm saying is that the static LSP has a T specific characteristics, and hence it should be under the T yang. Otherwise, where would you get that? You will have to do it on the static itself. It would be duplicate.
Himanshu, I think this is a bit detailed and that we can't really take this discussion here. It's a typical thing to take to the mailing list. And
We'll discuss after.
Yeah.
Thank you.
So Fung, it's your. Are you?
I'm done. The last slide I had is the next steps. So we did want to converge on the open issues, and next address the segment routing traffic engineering module. That's it.
Okay. So please go ahead. If you take your 10 minutes, we're a little bit over, but we don't care.
The session formally ends in 4 minutes, though.
Try to make it 7 minutes.
Yeah. Okay. Do you have a slide?
Not yet. Yeah.
I don't know. So we get the.
Yes. Hi, this is Xufeng Liu from Ericsson, reporting the status of T topology EM model on behalf of the design team. So since last IETF session, we have done a few things. Here's a summary what we have done. We have completed alignment with the I2IS network generic network topology model. We have added a few features, including support for multi-access links, inter-domain links, IACD recovery status, and we also have moved the scheduling parameters into a separate model. So what we have done with the I2IS generic network topology model is that we augment that generic topology model. Mostly what we need to do is to the key mappings. The generic network model consists of networks, links, node, and TP, termination points. So what we have done is we map our network topology to the network entity here. Then we map our T topology IDs, the provider ID, client ID, T topology ID into the primary key of the network ID. Then we map our T node ID to the generic network topology node ID. We keep our node ID at the alternate key. So we did similar things to the TP ID. So we have our own TP ID and then use the generic models, the TP ID as the primary key. So then we have a T-link, which is inherited from the generic model. We don't need to do anything here because they already have the primary key at the link ID, and also they also have alternate key to provide the source destination. For the features, we added support for multi-access links. So what we have done is add an attribute to the link to indicate this is a multi-access link, and the system will generate a read-only pseudo node with the flag saying that this is a multi-access DR. We added support for inter-domain links. So on the link attributes, we added the configuration container, so which is a list of this is an inter-domain ID. So on the node, we added a flag to indicate the domain ID, so that we know which domain this node belongs to. For the ICD, we added a list of adjustment capabilities, so that we can have the information about the upper layer switching capability. So we also added the support for the recovery status, which can be protection status or recovery restoration status. Then we moved the scheduling parameters into a separate model. This will be a separate document later on. Then we have a to-do list on our GitHub. So we have received some comments, and we'll complete those comments and update our document. And we welcome further comments. That's it.
Okay, any questions? We are a little bit over time, so if you have questions, be crisp about it. Okay, so thank you, and thank you for joining our meetings. See you next year in South America, I think.
And thank you to the MPLS chairs and working group for hosting TEAS.
Actually, I will send out a mail on those mailing lists and ask if this is a way of thing we want to do next time also, a little bit ahead of the meeting and not doing it during the planning of the meeting.